Artificial intelligence is a very quiet field at the moment, but it is an increasingly vocal field. Its roots go back quite a long way. Officially, its origins date back to a conference at Dartmouth College in 1956, where the great scientists of the time, such as John McCarthy and Marvin Minsky, came together. But still the father of artificial intelligence is considered to be Alan Turing, who was also the father of computers. Although the artificial intelligence is a very fast-growing field, why does it constantly go through periods of pause? Because scientists are pursuing a goal that can be considered a very extreme fantasy, robotic thing, understand, perceive. However, our technology does not yet have the power to support such a complexity. Therefore, technological inadequacies slow down the pace of artificial intelligence research every 10 or 20 years. At that time, scientists are not stopping. Of course, they are focusing on overcoming the problem. Immediately after that comes a boom period. Countless topics that lie at the heart of artificial intelligence, such as fuzzy logic, artificial neural networks, have always gone through such periods of pause rebirth. So, what are the problems that challenge scientists? There are many problems such as the limitations of progresses, cost unknown, quantum mechanics, but we are overcoming them one by one, and as we overcome them, our robots are getting smarter. Of course, we should not think of the artificial intelligence as just a robot. That is, a structure similar to a physical being. Artificial intelligence doesn't have to be installed on a robot. It can also be just a software. And I'll tell you already, do not expect groundbreaking, revolutionary inventions in artificial intelligence from robots that walk, run, and look like humans in the first place. It will come from work that looks like ordinary computer software. There is no end to counting the areas of use of artificial intelligence. In many countries, doctors use artificial intelligence software known as expert systems. For example, based on the patterns of symptoms, they scan a huge medical database that the doctor cannot keep in mind, informing the doctor of possible diagnosis in a matter of seconds. However, unlike ordinary software, they are able to learn from previous experience and identify similar patterns. Think about it. How likely is that a doctor will remember a patient with similar symptoms and all the details that they looked at 25 years ago? But an artificial intelligence can even remember how much of the patient's bread they ate on the second meal of the third day the patient arrived at the hospital and include it in the dataset. Of course, I gave a somewhat extreme example, but I'm trying to explain the limitlessness of what can be done with artificial intelligence. Expert systems, which can be considered the most basic form of artificial intelligence, are able to overcome such problems in a relatively short time. Similarly, there are specialized systems that are engaged in geological and biological research. In research that depends on a large number of variables, it can be extremely difficult to make certain determinations for people. For example, if you try to evolutionary analysis of 60 different species over the last 300,000 years, you have to deal with a tremendously large set of data. The algorithm underlying artificial intelligence helps us to overcome this problem. But these are not the artificial intelligences that people want to see. Of course, people want to see software and robots that think, make their own decisions. This is multi-layered research, so it is not possible to get in its final form at once. Let's not forget, we are trying to produce an intelligence such as nature and evolutionary progresses have been able to produce for 4 billion years with only the last few hundred years of our science. Therefore, difficulties and disruptions are very normal. Despite this, the path taken is become designing and increasingly exciting. In order to make great leaps from calculator level tools to quantum computer level systems in an imaginary engineering universe called the designing universe, which contains all possible designings. In just a few decades, we need to equally great discoveries. As with all technologies of the future, this is the limiting factor in artificial intelligence. Nevertheless, we will get there in time. Robots, as people would like to see, have been in commercial use in Japan for quite some time. There are restaurants where robots have been working as waiters since 2010. As robot research in Japan can be considered the leader in the whole world. Such purpose things come to them earlier. These robots are robots that can ask you what you want to eat, place an order, be kind to you and serve you. Again, Japan introduced its first robot, NIS server to the public on June 24, 2014, for example. It is almost impossible to distinguish it from a person. He perfectly masters the language and even has a sense of humor. In addition, there are non-commercial, experimental robots. The most famous examples of these are Professor from Osaka University, Dr. Hiroshi Ishiguro, humanoid robots belonging to. These robots are aimed at understanding what it is to be human. It is not just Japan. Very extensive and high-level research is also being conducted in the United States. Artificial intelligence, one way or another, sooner or later, will build our future. It will surround us. The words of investor and entrepreneur Elon Musk, who has recently spent a lot of money on artificial intelligence, on the issue are striking. Artificial intelligence studies will unleash a monster, and if there is going to be investigation into this, I'd look like to know about it, said. What do you think about artificial intelligence? Please indicate in the comments. See you in the next video.